Hello and welcome to this presentation and demonstration of Internet of Things and Arduino systems. I am your presenter Hurambe. Through this presentation we are going to look at our systems using system sketches in the introduction part of this presentation. Then we will look at the materials and methods used to build these systems and what did we get as a result of these systems and in the end analysis and a little bit discussion on vital components of these systems. So first of all, we have an IoT system which will perform programmed activity and store data over cloud. In this system, we have an Arduino board which is getting temperature and a set point as an input, and output of the system is it's controlling an air heater process in order to maintain temperature. But first, rather than using a physical process, we are going to use air heater simulator, in which we are using discrete mathematical equations, the Euler form, to simulate the air heater process and PID controller. Then of course we'll be having some status LEDs over the circuit to quickly get the status of the circuitry without looking at the user interface or serial monitor, for example. And since our Arduino Uno is a simple Arduino Uno, it do not have Wi-Fi capabilities, and in order to add Wi-Fi capabilities, we are using external Wi-Fi shield Adafruit ESP8266 type, which will communicate with the Arduino Uno and further connects with the Wi-Fi and store or communicate data to ThinkSpeak cloud. And a little bit about ThinkSpeak. ThinkSpeak is an IoT service that lets you collect and store the data in the cloud. It's free for small and study purpose projects. Another part of the system is like we are going to use LabVIEW links instead of Wi-Fi shield. You will be using Arduino Uno as a DAC data acquisition device. We'll get the temperature in our system, and our simulator will be running into a LabVIEW. And LabVIEW links, by the way, links is an add-on in the LabVIEW which can use to control or communicate with the Arduino Uno platform. And then in LabVIEW, so we have like built-in HTTP client function that we can use to communicate with ThinkSpeak Cloud. Materials and software used are Arduino Uno, Adafruit ESP8266 Wi-Fi shield, resistors, potentiometers, LED capacitors, resistors and capacitor for making RC circuit, LEDs, status LEDs, wiring USB cables, and breadboard. Software are Arduino IDE, which is a tool for downloading or uploading program into Arduino board. Visual Studio is used to build like library, which we are using in IDE, Arduino IDE. LabVIEW, ThinkSpeak, and Links add-on. Circuitry and protocol circuit we are going to look at in a bit. RC filter for PWM. As we know, Arduino don't have analog output, so we are using RC filter for pulse width modulation and mimic the analog output. potentiometer is used for providing the set point to the system. We are converting this voltage into set point in our system. Serial communication for download and serially monitor Arduino Uno. And serial communication between Arduino Uno and Wi-Fi Shield. Arduino Uno is sending data, simulated data to Wi-Fi Shield, and Wi-Fi Shield is sending over Wi-Fi WPA to personal security protocol using this protocol for communication with ThingSpeak. And of course, the HTTP and protocol is used by ThingSpeak server. Here is our circuit. This is Arduino Uno and Arduino Uno board, and this is Wi-Fi Shield. This is our temperature sensor. We are getting input into our Arduino Uno, and here is the RC circuit, pulse width modulation. This is set point is going into our Arduino Uno, and here we are communicating between Arduino Uno, sending the data to Arduino Uno from Arduino Uno to ESP8266 Wi-Fi Shield. So let's have a look on a video of the circuitry. Here the blue LED is representing that it's sending the data. And here is a potentiometer. It's a program like if set point is away, very near. So here, as soon as set point is away from current temperature, so LED blinks. And this is like USB cable for downloading or serially monitoring Arduino Uno, and this is TTL to USB cable in order to download into Wi-Fi Shield. So we have two programs separately downloaded into these chips. So let's look at the code. Here is the code for Arduino Uno. So we're using the serial transfer inbuilt libraries, and this is lab 1 is actually library we have developed for simulating filter, air heater simulator, and PID controller. We can have a quick look over it. This is the header file in which we have defined low pass filter, discrete check controller, air heater simulator, and these are discrete other equations which we have simply implemented in this library and later call this library here in Arduino IDE. So here is the data which we are going to send to ThingSpeak. Here is the declaration, initialization of variables. Then we are starting our serial communication. We are converting voltage into set point, and then here are the equations or calling of functions from lab1 file. Then we are sending this or storing these points into our IoT data, which we are later going to send to our Wi-Fi chip. Here is the code for transferring the data to Wi-Fi chip. And we have separate data or separate code for Wi-Fi chip. quite standard program because of availability of libraries in IDE. So we have used just standard libraries. Here we are passing SSID, secret pass, and channel ID and API key, all stored in here in header secret.h header file. So we are gonna look into it, the secret channel ID and API key from ThinkSpeak very soon. So here we are defining our data structure, status LEDs, and we are simply transferring this to ThinkSpeak. Here is a bit about ThinkSpeak. Channel ID. This is a write API key. We have initialized 4 fields: temperature, gain, NTI, and set point. So in order to write to our ThinkSpeak, we have to pass this write API key and channel ID into our program, which we have done. And then similarly, LabVIEW, we are getting our temperature and set point, converting into voltage. Here is the filter, simulator, and simulation button, and then we are feeding this into our by using these standard blocks available in LabVIEW HTTP protocol. We are sending this to ThinkSpeak. We're going to look this in demonstration. User interface is this, like this is a waveform simulation, serial port, API key, field. So we're gonna look into this. So in demonstration, we can first of all we can look into right now. I have my kit connected to my PC. So if we go to simply serial monitors, we can see that here our controller, here is the set point, and controller is meeting set point. It's a bit slow, but it's going up. Even better, we can see in serial plotter. So simulation is working like it is in right direction, of course. Tuning of controller can be done to perform it, have a better performance. And if we look into our ThinkSpeak, so here is the data, temperature, KP, TI, and set point. So it writes every 15 seconds. And likewise, we have we have this simulation which we can run for LabVIEW. So here we have to so our controller is simulating set point. Yeah, so it follows the set point, and here is it's writing to ThinkSpeak. So at the end, so a little bit about cyber security. As we know, security is the main ingredient of any audio application because it communicates over network. So here we are using write API and channel ID, which is like credentials, and it provides us security. We can also look into restricted channel access. Do not make it available for public, or trying to implement different restrictions. Encrypted communication over secure Wi-Fi. We should avoid using like Wi-Fi without security protocols. And of course, ThinkSpeak server has its own HTTP and MQTT protocols for secure communication. Thank you.